This question is from GATE Mechanical Engineering of 2014. This is question number 34 of set 1. The question is, an ideal water jet with volume flow rate of 0.05 meter cube per second strikes a flat plate placed normal to its path and exerts a force of 1000 Newton. Considering the density of water as 1000 kilogram per meter cube, the diameter in millimeter of the water jet is, so we need to find the diameter of the jet, okay, and that too in millimeter. So from Newton's law of motion, we know that rate of change of momentum in the direction of force is given by, actually, second law of motion. The rate of change of momentum in the direction of force is given by Fx in x direction. Force in x direction is rate of change of momentum by rate of change of time. Okay, also we write it as dm upon dt. So this will be, now according to conservation law, the momentum equation of fluid, we can write rho a v into initial velocity minus final velocity. So in the problem we are given the flow rate is 0.05 meter cube per second. Now force in x direction is 1000 Newton. Okay, density of fluid, that is water, is also given. Okay, if it's not given, we can take it as 1000 kilogram per meter cube. Okay, now if we substitute that in the above equation, we can write 1000 is equal to 1000 Newton, so, and density is also 1000 multiplied by a into v multiplied by v minus 0. Why? Because this final velocity when it strikes the plate will be equal to 0, okay, and initial velocity of the jet we are considering it as v. Okay, this is also the initial velocity, so this will be equal to 1. We can just cancel out these zeros, so 1 is equal to a times, now we can also write this as, this is v square, right? So v square we can write q upon a whole square, because velocity is equal to flow rate divided by area. Okay, so from here a is equal to, because this one a will get cancelled out, another a in the denominator will, when we cross multiply it, we can write a is equal to q square, and that is equal to 0.05 square, because q value is 0.05 meter cube per second. Okay, now the area of jet, we are considering the jet to be cylindrical, so this will be pi by 4 d square. The cross section of the jet will be circle, so this is pi by 4 into d square is equal to 2.5 into 10 to the power of negative 3. So from here we can get the value of d, that is 0.05641 meter. Okay, and we need to find the answer in millimeter, so d will be equal to 56.41 millimeter. Let's go back. So the diameter of the water jet in millimeter is 56.41. For more information, you can refer to the NPTEL course, lecture number 13, Conservation Equations in Fluid Flow Part 1 on Fluid Mechanics by Professor S.K. Soam of the Department of Mechanical Engineering at IIT Kharagpur.